Okay, so again, starting off with the domain, we're looking at 2x minus 6 is 0, which means 2x is 6 and x is 3. Again, some people write a not equal to symbol through this. That's up to you. As long as it leads to our domain, and I am going to write this in interval notation to match my directions, negative infinity to 3 union 3 to infinity. Okay, so what this means for us now is we want to show what happens to our function, its behavior, right, around this excluded value of 3. So I am going to kind of box this off as part of our answer, but now we want to discuss, I guess, for lack of a better word. So we're going to look at x and f of x. Thought I turned that blue. Okay, so let's do values on the left. And I'm okay with 4. We don't have to do 5 like we did the last couple. So x and f of x. And we're trying to approach 3 from the left. So let's start with 2. So you have 2 times 2, let's just parentheses, plus 5 over 2 times 2 minus 6. So 2 times 2 is 4, plus 5 is 9, and 4 minus 6 is negative 2. 2 and a half. So 2 times 2 and a half plus 5, 2 times 2 and a half minus 6, minus 6. Okay. 2 times 2 and a half is 5, plus another 5 is 10. Again, 5 minus 6, that's negative 1, so you've got negative 10 here. let's do 2.9. So 2 times 2.9 plus 5 divided by 2 times 2.9 minus 6. So 5.8 plus 5, that's 10.8. And 5.8 minus 6 is going to be negative 0.2. Now, it's a bit awkward to have fractions and decimals all in one spot. So we can move our decimal over one spot for both of these. And that gives you 108 divided by a negative 2, which is just negative 54. Okay, we are allowed to do that decimal movement as long as they're equally moving equally, right? So I can't do the top twice and the bottom once. It has to be the same. 2.99, and this can be our last one. So 2 times 2.99 plus 5 divided by 2 times 2.99 minus 6. This is 5.98, so plus 5, 10.98. And then in the bottom, minus 6, negative 0.02. So again, I'm going to move my decimals over twice. 1,098 divided by negative 2 gives us negative 549. Okay. So I would say as x approaches 2 from the left, f of x approaches, these are decreasing pretty significantly, right? Negative 9 over 2 all the way to negative 10, negative 54, negative 549. So I would say negative infinity. Now, one note or kind of comment I want to leave here is there is always this question of what numbers are good enough, right? You can see I pick roughly the same numbers or the same pattern of numbers, but does it have to be those every time? The answer is no. It does not have to be the same ones every time. And how many do I need? And the answer is you need enough numbers that are close enough to whatever your excluded value is so that you can tell what's happening. And there is kind of enough where I can tell that you know it as well. Like maybe if you just stopped after 2, that's probably not enough. I know enough is not the most scientific of terms, but that is one thing you kind of learn and develop more as you take more math classes, right? Think of it in this context. You want to convince me that you know what you're doing, right? So you want to give me enough evidence laid out across these values here, right? So when I look at it, I go, oh yeah, they have shown me, or it's really clear why they got their answer, right? That's some of the mentality you want to come in. You're almost like it's a courtroom kind of thing where you're trying to justify to me why I should believe this is the answer, okay? And that's a bit of a shift because that's not really what we're used to as math students, right? But that's where we want to go. So now we want to look at the right side of this number. So again, x and f of x. And we've been writing this on the left. So you could write x approaches 3. I don't know why I wrote a 2 back here. That's definitely a 3. Let me fix it. On the left. And here we're looking at 3 from the right. What is f of x doing? And I also do not want you to make assumptions, right? Don't assume because one goes to positive infinity, the other has to go to negative infinity. We will see examples where they agree with each other. Maybe they both go to positive infinity or they both go to negative. The idea, as long as they are either increasing or decreasing without bound, that is our kind of verification that this is not in the domain of the function. Okay, so let's work again. We kind of balance out what we've got up there. So 3.01, 2 times that 3.01 plus 5 divided by 2 times 3.01 minus 6. So 2 times 3.01 is going to be 6.02. Add 5, 11.02. Divided by 6.02 minus 6 is just going to be 0.02. Again, same story as before. Let's move our decimals over 2 places. You end up with 1,102 divided by 2, which gives you 551. Again, keeping in pattern, 3.1, so 2 times 3.1 plus 5, 2 times 3.1 minus 6. That's 6.2, so 11.2 divided by 6.2 minus 6 would just be 0.2. Again, move your decimals, this time only 1 place over, and we're left with 112 divided by 2. 56. Okay, let's do 3.5. 2 times 3.5 plus 5, 2 times 3.5 minus 6. 2 times 3.5 is 7, so add 5 and you get 12. 7 minus 6 is 1, so we just get 12 there. And let's do 4. Again, 1 digit away on the number line, so 2 times 4 plus 5, 2 times 4 minus 6. 2 times 4 is 8 plus 5 is going to be 13, and 8 minus 6 is 2. So again, the question, and I sometimes feel like the right side is maybe not as clear when we're looking at it. We are looking at these function values. However, we're looking at them moving in this direction, right? Because this is where 3 would sit. And I'm drawing this almost as if I was on a number line, right? So 3 is here. We looked at 3.01, 3.1, 3.5, and 4. It's very squished together, but I'm moving in this direction as I go. So from 13 over 2 to 12 to 56 to 551, what is happening to f of x? Those numbers are increasing, seemingly without bound. Again, you can always add more numbers in between here, right? 3.001, or add as many zeros as you want. I would say it goes to infinity. So if I was to put this in words, something like, as x approaches 3 from the left, f of x decreases without bound. That's that, I think we said towards negative infinity. And as x approaches 3 from the right, f of x increases. Let's see, without bound. this time towards infinity. And again, it's always, or it should always be without bound. We're going to touch on that on the next page for some of the support.